Okay, as you saw just there, we're also getting this live streamed to YouTube. So if anyone has any reason that they're not able to be here right now, that this will be available to you as a resource. We're also getting this God, live why is that to YouTube? So okay. Okay, cool. So yeah, it looks like we've about evened out on participants. So we're going to get started here. First, just for some introductions. Everyone, my name is Aidan. I am a freshman in CS here at UIUC. I'm also the GitHub campus expert to UIUC, as well as doing a bunch of other things. And I am going to be going over some of the more technical aspects of things that you need to get ready to participate in a hackathon.
Hello, everyone. My name is Garima. I'm a CS Plus advertising major here at UIUC. I'm involved in HackIllinois as well as in other RSOs and clubs on campus, as well as off campus, and I will be leading the team formation event today.
So also just before we get started, I sent out a message in the Discord about an hour ago with some initial sort of setup instructions that are going to be relatively important for following along with today's event. First of all, if you're on Windows, hopefully you had a chance to install Windows Subsystem for Linux. That will give you, just like an actual Unix shell in whatever Linux distro you ended up picking to install there, which is going to let you follow along with the stuff here. If you don't have that done, there's a link on how to do it in the Discord. If you're not, I know it has a pretty big download associated with it. So if you're not able to do that right now, I just wouldn't worry about it. You can watch along right now if you want, or you can just go ahead and catch up on this on the YouTube version of it. And past that, you should all also have Git installed on whatever you're doing. So if you're on a Mac, go ahead in your terminal and you can just do git -- version. If this runs correctly, then that means you have Git installed. This is the same command on everything. Everything I'm doing will be applicable to either Mac or Linux, and by extension, Windows Subsystem for Linux. If you don't have that set up, there are instructions in the Discord. Go ahead and follow those. And then you can either use the resources that I'm going to send out at the end, or you can just watch the recording of this if you want to catch up on that bit. But I would definitely stick around so that you're here for the team formation part at the end. Okay, so with that, I think we are going to get started on the actual workshop thing. So first of all, if you want to follow along, go ahead and open up a terminal. It's probably not going to look exactly like mine because I'm a huge nerd and customized mine a bunch. But it should give you some sort of prompt where you are able to type things. We're going to start off by really quickly going over some basic ways to interact with a shell on any Unix-based system, which is going to be really useful to you just in your life as a developer, and especially right now when you are working with Git. So basically what a shell is it is a text-based way for you to interact with your computer. Just like you can open up an app and do something on your computer like that, the terminal is able to do a bunch of stuff on your computer as well and has its own programs associated with it that you're able to run. So the way that the terminal works is at all times, you will sort of be located in a file. So if you think about what it looks like if you open up like Finder on your Mac or File Explorer on Windows or something like that, you're always in some sort of folder and you can see the other files and folders that are inside of there, as well as move around those folders, and then you'll like sort of be somewhere else in your file system, right? So the same exact thing applies when you're in a Unix-based shell. So here, for example, we're going to learn our first command for this right now. There is a command, pwd. So pwd stands for print working directory. This is just a way to see what folder you're in at a given moment. So this is really helpful if you need to figure out sort of where you are in a file system and sort of move around based off of that, just so that you can sort of know what you're doing. So that would be sort of the analog to that would be in like Finder or File Explorer, like the top bar that shows the current location of where you are. This command is sort of equivalent to that. So the other thing that you're going to need to sort of look at where you are right now is ls. So ls basically just lists absolutely everything that's in your current sort of folder that you're in. So for example, here I'm just in my sort of main home folder where all of my stuff is. So you can see all of the things there. And going based off of that, we can learn yet another command right now. So cd stands for change directory, and this is how you actually move around your file system. So when you're doing change directory, there are two sort of things you can do. You can either do things called absolute paths. So absolute paths will let you type in like the full sort of file name or folder name of somewhere where you want to go, and it'll move you to that. So that would be something like /users/Aidan/projects or something like that. Or you can also do relative movements. So with that, that's going to be just sort of based on where you are. It's going to move things based off of that. So for that, since I'm already in /user/Aidan, here I can just go to projects, and that will move me to that same place that that absolute file path would have. So that's basically how you go ahead and move around your file system. So now that we have that covered, that is, again, a super, super basic introduction to Unix shell stuff. There's going to be a Discord post after this in the workshop recordings channel that's going to have both a link to the archived YouTube live stream, as well as a bunch of other resources that are completely shameless plugs to my YouTube channel that I haven't touched in several months. So if you want to check those out, those will have some more in-depth resources on both how to use a shell and how to use Git, as well as some other text-based resources that you can just sort of use as a reference throughout the event. So now that we have that basic shell stuff covered, I know I went through that really quickly. If you didn't catch everything, again, not a problem. We're going to move on to talking about Git. So first of all, we're going to go over what Git is, why you should care about it, and how you're going to use it throughout this event. So Git is what we call a version control system. And basically, it is a way to manage versions of files, exactly what it sounds like. So you know how sometimes, let's say you're writing an essay or something like that, and you might have a file called, like, I don't know, the title of your essay .docx or something like that. And then after that, you might have another file. Once you go through a few edits, since you want to have both versions, you'll have like the name of that essay final .docx. And eventually those can compound. As long as you keep sort of making updates, you might create more and more of those new files. And then it gets super messy, and it's just really a bad time to try to figure out what version of how many times the word final appears in your final draft and whatever, things like that. So what version control systems do is they deal with keeping track of the changes between files instead of just having entirely new copies of files, which is just a much easier way for you to deal with sort of different versions of things. By extension, since they're good at that, they're also really good at collaboration, because you can see how other people changed the files that you worked on. And from there, you are sort of able to extend that to what your files should look like right now. And that's just a great way to keep everyone in sync. So we're going to be going over a few different things today. We're going to be going over just Git, which is just a command line tool that is like open source, ships as part of basically most Unix operating systems, and is used for the actual version control. And then we're also going to be talking about using GitHub. So GitHub and Git, while they are obviously related, are not quite the same thing. So GitHub is a private company that sort of hosts Git repositories. And it's a way for you to be able to deal with code that is sort of remote, right? So you'll host your code on GitHub, and then you'll also have a local copy. And from there, you'll be able to sort of make changes on your local side, push it up to the server, and then everyone else who you're working with is able to pull down that code and work on it as well. So again, another one of the things that I sent out in the Discord channel before this, you should have a GitHub account set up. If you don't, that's, again, relatively easy. You can just go ahead and look up how to do that. And that should sort of cover all of that stuff. So now that we've sort of got that covered, we're going to move into actually talking about how we're going to use Git, and especially how you can use it when you're working on hackathon projects, especially in a remote hackathon like this, where the people on your team are not necessarily in the same room as you. So there are a few different ways to create a sort of Git tracked project. Basically what Git does is it just keeps a folder inside of your project that's keeping track of all the different changes. And that's sort of how it's able to interact. So when we're creating a project that we want to track with Git, there are two ways to do it. We can do it locally. And to do it locally, we would first want to just make a folder and then tell Git to track it. Or we can actually do it on GitHub, which will take care of some of the setup stuff for you, which is going to be a little bit easier. So especially since most of the people here, I'm expecting, haven't worked with Git in the past, that is how we're going to be doing things right now. So to go ahead and follow along with that bit of things, go ahead, open up a web browser, go to github.com, and we're going to work through creating a new repository and then starting to contribute to it. So once you go to GitHub, if you're not logged in, go ahead and do that. And then after that, you should have a button either on the left right here. There's a new button, or there's a plus button up here. And oh, actually, wait, I am not sharing Chrome, am I? Sorry, 1 second. Okay, cool. Just can someone let me know if you guys are able to see my GitHub right now?
We can see it.
Okay, cool. So yeah, so over here on GitHub, this is actually where we're going to be doing our project creation, just for this sort of example of a project, just so that everything is already tracked remotely for you, which will make the collaboration aspect of things a lot easier in the future. So here, there is this new button right here that you can use to create a repository, or if that's not showing up for some reason, you should also have a plus up here in the top corner where you'll have something that says new repository. So if you go ahead and click through that, then we will get a little form right here, which is just going to guide us through the creation of our repository. So the first thing that you need for your repository is a name. Here, this is just basically what the name of your project is. This is going to be what the folder is called by default, and also just sort of what the name of your project is. This is what you're going to want to call it. So if you're here, I'll just call this like crash course example. So there are other things that you can sort of add to your GitHub repository. You can put a description. So I can put, this is an example repo for the hackathon crash course at HackIllinois 2022. Then you can determine if it is public or private. Here, I would just recommend leaving it public. The use cases for private repositories are going to be more if you are in like an organization that needs to keep track of their code without necessarily making it viewable by everyone. If it's public, everyone's going to be able to see your code. But again, that's sort of the default option and is the easiest to deal with. And then from there, we have different ways that we can initialize our repository. So if you made a repository locally on your machine first, and then you're just pushing it up to GitHub, you wouldn't want to use these options. But here, since we're creating our repository in GitHub before pulling it down locally, we can go ahead and add all of these. So there are a few sort of main things that are part of a GitHub repository that almost every GitHub repository has that we are going to want to add right here. So the first is a README. So a README file is basically just a text file that gives a bunch of instructions for how to use a project or description of what a project does, or sort of general information like that. And then the next thing that we're going to use is a git ignore. So what a git ignore file does, and we'll get into this a little bit more soon, is it basically keeps track of a bunch of patterns of files that you don't want to push to GitHub or track with Git at all. So for example, if you have, I don't know, big files that are generated by your program, but aren't necessary for how the program works. Let's say, I don't know, things like output that might be in the same sort of directory as your project, but aren't part of your project's code, or other things like, I don't know, like an executable that you get from compiling your project. Those you generally don't want to track with Git. So those you would add a pattern that is going to match those to your git ignore. Git ignore is also super useful for if you have anything secret that you don't want shared with the world, and therefore you don't want tracked in Git. So if you have things like API keys or environment variables, which you might, API keys are especially something you might run into if you're trying to make a hackathon project that works with another source of data, for example. Generally, you're going to want to put those in a file that is included in your git ignore so that those don't become public to the world and everyone else doesn't end up using your API keys. So there are a bunch of also nice templates for git ignores that you can use sort of based on what language your project is in, which just has like a nice sort of template of things that you often want to ignore. Here, we're not going to be doing any actual coding in this repository, at least in my example. So I'm going to not touch that for now. And we can maybe discuss it a little bit later. And then finally, another thing that is pretty important is having a license. So what a license is it just sort of outlines the different ways that you're allowing other people to use your code without having to specifically ask you for things. So the sort of world of open source licenses is, I don't know, rather complex. GitHub has a really nice page sort of explaining what each of these licenses allow different people to do with your code. But we're not going to get into that right now. So I am just going to add the MIT license to this right now, which is a pretty permissive license that just allows people to work with my code in the future, should they so choose. So then once we have all of those set up, what is going on here? Why is create repository grayed out? Am I missing something? One second. I'm not sure what's going on here. Oh, okay. Is it just mad that I don't have a git ignore template, maybe? Yeah, okay, so that was it. So yeah, I guess just sorry about that. So then we can just create that green create repository button, and that is going to bring up a page that looks like this, which is our actual repository, which now exists on GitHub. So the next step is going to be pulling our repository down. So there is a little bit more setup you're going to want to do, and this is something that GitHub has a really great page about, again, that you can go to. You can just look up add SSH key GitHub or something along those lines, and that will sort of guide you through it. But basically, since we don't want just anyone to be able to push to our GitHub repository, you need some sort of way that GitHub is going to know who you are and sort of go based off of that when you are trying to push code to your repository. So again, not going to go into that now. There are setup instructions which are linked, I believe, on the Discord. And then past that, basically, you're just going to want to do things with that. So either SSH or HTTPS here should be set up, hopefully. If you have issues with that, try to contact one of the staff members who are here or on the Discord, and they should be able to walk you through that setup, or feel free to reach out to any of our awesome mentors as well. But basically, we can grab that URL, and if we want to then pull it down to our project locally, we can do git clone and then paste that. And from there, that is going to clone into a directory, which is named the same thing as our project is. So now if I run ls again here to list all of the projects that I have, you'll see there are a bunch of different projects, but we can cd into, what did I call that? Crash course example, right? So crash course example is now going to have that Git repository. Again, if you are having trouble with this or something's not working right here, the most common issue is probably that you don't have your identity sort of set up on your local machine. So again,
wait, Aidan, I think you weren't sharing your, or you were
Oh,
sharing your
right.
account,
Google
but you
Chrome
didn't
tab still.
switch.
I keep forgetting to switch that share. That is my bad. Back to here. Okay, sorry. So now we're back on here. So basically what I did right there is git clone, and then that URL that we copied from that little drop down on GitHub, that is going to sort of clone the repository that you are working in. So then from there, that'll just create a directory in the folder that you are currently in, which is named the same thing as your project. And then you can just use cd to move into that directory. So now we're in our directory and we can start actually working with our project. So what we're going to do here, actually, I am going to switch my share to share my entire desktop just because we're going to have multiple apps open now. So, okay, so now you should be able to see my entire desktop, which would also deal with issues in the future. So now we are in our project repository. The next step you're probably going to want to do is opening up your project in whatever editor you prefer to use or you plan on using for your project. For me, that's VS Code, which I can just invoke by doing code dot. And then that will bring up VS Code over here. And there we go. So now we can see that I have access to that in here. And then actually, I'm going to bring up a terminal in here just so we can keep everything self-contained. Cool. So now, oh, that enlarged the whole thing. Okay, so now we have our repository set up and we are ready to sort of learn how to interact with Git in such a way that we are able to keep track of our projects. So the way that Git works, as we explained before, is by keeping track of the changes that you make to files. Those sort of changes could be creating a file, they could be modifying a file, deleting a file, anything like that. So to get started on this, we're going to go ahead and create some files. So we can just create one. I'll just do like, I don't know, we'll do a Python file. We can call it example.py or something like that. And then from here, as you can see, since my VS Code is set up to sort of integrate with Git, it sees here that this is a new file and it's highlighting that for me. That might not happen for you, but don't worry about it. Everything that I'm doing here completely isn't affected by the editor. We're just going to use the terminal anyway. So we created a new file. So now we want Git to actually track it so that we can sort of have it as part of our project. So now we are going to go through a few of the Git commands, which are going to allow us to sort of interact with things here. So for example, here, if I go ahead and run git status basically just reports on what the status of our current folder that we are in is compared to our repository, which then allows us to sort of, I don't know, keep track of our state and work on it based off of that. So here we can see we're on the branch main. I think that GitHub is now fully rolled over every main branch to be called main. If you're on a GitHub repository that was created before, I think it's a few weeks ago, this might be called master instead, which could get a little bit confusing. So basically anywhere that I use main here, you might need to substitute for master if you end up getting errors, but don't worry about that too much. So we are on our main branch, as we can see. We are up to date with origin main. So what origin is here is that is the name of, you can sort of imagine we have our Git repository on our computer, and then the GitHub servers have their own version of this Git repository up in their servers. So this origin main is sort of the remote version of our Git repository, which exists on GitHub servers. So now if we want to go ahead and make it so that our repository is tracking that file, we can learn our next important Git command, which is git add. So what git add does is it just tells Git to sort of take a look at the files that we are going to indicate right after this. And from there, sort of, I don't know, either do something with them or I don't know. Well, actually, I will show you what we're going to do with them after. So you can run git add, and then you can either put the just full on name of a file, like the path to that file from where you are, or if you are in the root of your project directory, so you're like where you created your project and you want to just track everything, you can also do dot, which will track everything in the current repository or in your current directory. And if you want to track absolutely everything in the project that's been updated, you can do -- all as well. So that will just track all of the changes. So now we can think of it as our files before were just being completely untracked. Git didn't care about them. So now they're in a state that we call staging. So now if we go ahead and run git status again, we can see we have a new section here. Instead of being in untracked files, our example.py file has moved to changes to be committed. So what changes to be committed is saying is it's basically just saying the next time that you commit to your GitHub, the next time that you commit to your Git repository, these are the changes that Git is sort of going to make happen. So we can see here that we have a new file called example.py. So now if we want to actually have Git track those changes, which we haven't done just yet, we can now run a commit command. So for that, we're just going to do git commit and then -m. So what -m is just dash message. This is a way, every Git commit that you're going to make, you're going to want to have a message associated with it that sort of explains what changes you made up until this point. -m is just a nice shorthand so that you can put that message in line with your Git commit instead of creating a separate file or having it open up an editor for you to do that in. So then here, we can now go ahead and type our commit message. So for this, let's just call it, I don't know, create example.py. So now this is just going to be a very short tangent to explain sort of an industry best practice that has to do with your Git commit messages. And that's that all of them should be in this form. It should be sort of like a command that you are issuing to Git, right? So you're telling it to create example.py. You would want to type this instead of something like created example.py or anything that's like in the past tense. That's just sort of a standard thing. You can get into the semantics and philosophy behind it, but I don't really think it matters too much. That's just kind of what everyone does. So if we go ahead and run that now, we'll see we get a message that says we have one file changed. And then these numbers right here are talking about the number of lines that change. So the way that Git works under the hood is sort of by tracking the similarity between all of the files that were in the thing before a certain commit and after a certain commit by looking at the individual lines that are in it. So here, since we didn't add any actual lines to our example.py file, we don't have any insertions or deletions, but we'll be able to change that by adding some actual code in there later. So now if we run git status yet again now, we will see that we are on branch main. Our branch is ahead of origin master by one commit, which I'll explain in a second, and we have nothing to commit. So what this basically means is that our repository as it exists on our computer right now is completely up to date with the Git repository that's tracking it. So if we wanted to see that, we can run ls-a. So what A stands for is -all, and that basically just lists absolutely every single file in whatever directory you're telling it to, because ls by default will hide like hidden files. So here we can see that we have this folder right here called .git. So if we ls.git to just take a look, we can see that there are just a ton of files in here. And these are actually the inner workings of how Git is tracking what we're doing. What these actual files do is basically irrelevant to what we're doing. None of it will matter. You will never need to touch these files for like any basic project that you're working on. So I wouldn't worry about it, but basically just know that that .git file or that .git folder that's inside of your project directory is really what's keeping track of everything for you. So we can get rid of that. And now we can talk about how we interact with our remote repository on GitHub, because while we saw that we made a commit and Git now knows that our file has been created, if we take a look over here at our GitHub repository instead and refresh here, we'll see that it's still not there, right? We still don't have that example.py file in our Git repository here. So now we're going to talk about how you actually interact with the remote version of your Git repository. There are two main things that we're going to do. And the first one is going to be what you're going to do when you have changes that are on your local Git repository, but they're not yet on GitHub or whatever other remote you're using, but we're going to say GitHub here. And you want to make it so that they show up there. So when you're doing that, you're going to want to run git push. So push is basically telling it, take all of these local changes that I have and make the remote match them. So then from here, the next 2 words that you're going to type after a git push is first going to be the name of the remote repository. If you followed along with this, and in basically most systems where you're only going to have one remote, this will generally be called origin. So you can basically just like hard code into your memory typing origin there, although that will be different if you are working on something with multiple remotes. So let's say if you have like a bunch of different servers, you have like one server for testing and one server for actually publishing, and you want to have different versions of your app in different places, you might have different remotes so that you can track them differently. But origin is just the name of our remote. So that's like GitHub server is the way that we've been thinking about it. And then the name of the branch. So we haven't talked about branches just yet, but as I mentioned before, this will be either main or master, depending on when you created your repository and what settings you have set up in different places and what method you used and a bunch of other stuff. But basically try main. If it's not main, then try master, and it's probably master. So if we go ahead and run this now, you'll see that we get some information, and it's saying that it is basically sending off our changes to github.com : whatever. This is the Git repository that's on GitHub. So now if we hop back over to GitHub and take a look in here, we'll see that now our example.py file shows up. So that is sort of the super basic workflow of making a change locally and then making it appear remotely as well. So from there, now that we understand that, we're going to take a look at one more sort of basic thing, and then we're going to get into more of how you use Git in a way that's really good for collaboration and sort of accessible to everyone on your team. So quickly now, we're just going to sort of simulate a sort of situation here. If I'm going to create a file through the sort of GitHub web like UI here, and this is basically going to be simulating, let's say I had a teammate on the project I was working on, and they made a file and then they pushed it to GitHub. That would be basically the same thing as what I'm doing right now. So we can call this, I don't know, remote.py or something like that. And then, I don't know, we'll just do like print, this file was made remotely. So basically what I'm doing right here is I'm creating this file through GitHub to simulate having something that wasn't created on my local computer. So then we can just have a message associated with it, and we're just going to put that directly in our main branch right now. So now, as you see in our remote repository, we still have this, we have this remote.py showing up. But if we go into our local version instead, and we were to just run ls right here, you'll see we don't have that file that we just created remotely in our local project. So we need to find a way to get it, right? Because that's sort of the entire idea behind the collaboration here. So now if we were to run git status, you will see here, we don't have any changes here either. So our local version of Git has absolutely no idea that that file exists. So first, right now, we're just going to go through the sort of basic way. If you know one of your teammates made changes, then this is what you're going to want to do. And this is also just something that's good practice to do relatively often to make sure that you are staying up to date with what is going on remotely. So now if we go ahead and run git pull origin master or origin main instead, we had push in the earlier thing to make our local changes go to GitHub. So here we're going to do the exact same thing where we have git pull. And then the next thing is our name of our remote, which in the case of our GitHub repository is origin. And then the branch that we want to talk about, which in this case is main. So if we go ahead and run that, then we will see that, oh, it was able to pull something down from that crash course example. And now we have our remote.py file, which has those changes that we made remotely or that our teammate made or whatever the scenario is. So that is the sort of super basic sort of way of using Git remotely. But there is sort of one main workflow that we're going to have to discuss right now for using Git effectively, because there are a lot of issues that would arise if you just sort of worked like this. So let's say you were just using a workflow like this, where you were just pushing every time you made a new file or made a bunch of changes and pulling every time your teammate told you to because they made a bunch of changes. So that would be fine. You would probably stay up to sync, for example. But let's say that we made a change to example.py. We made this I don't know, I wrote this print statement. So if we have a change that we make locally right here, right, and then we go ahead and we commit it to our local Git version. So you can say, I don't know, update print in example.py. So let's say, oh, sorry, I forgot to add our changes first. So now if we make that commit, so now our local Git version sees that we just made a change to make the first line of example.py print, I wrote this print statement, right? So, but let's say that our teammate or friend or whatever also made a change to that file. So they went into example.py and they made this say print, I don't know, blah, something like that, right? So then remotely, they made a change that says, why is that in all caps? Update example.py remotely. So, and they pushed that to their sort of version of that, and then also put it on the actual GitHub server. So now what's going to happen? So if we run git status, we can see that we have that one change that we made, which was to make the example.py thing contain print, I wrote this print statement. So let's say that now we're like, this is what we want our example.py file to look like, and we wanted to push it remotely. So if we now did git push origin main, then we would see, oh, right here, we are getting that our change has been rejected. So right here, we can say updates were rejected because the remote contains work that you do not have locally. So basically, since someone else pushed to our Git repository, and then we made a change, we are not able to now push our changes because Git is sort of seeing that the history of the file on both of them, right? Because Git is just tracking the history of your project is different. And that is sort of causing an issue here. So what we would do for this normally is we would just run git pull first so that we have the most up-to-date version. But now if we see what happens if we run git pull origin main, we can see here, our file looks like this, which is not valid Python and also not something that we want it to look like, right? So here we can see that this is what is called a merge conflict. So we both made changes to the same piece of code essentially, right? Because we were both trying to edit line 1 of this example.py. And because of that, Git doesn't know what to do because it has no way of knowing which one we want to actually accept as the correct change. So it basically just leaves that to the user now. So we can see when we pull, we can see here, it's trying to auto merge example.py because it saw that there were changes made to both files, but then we have a conflict. So when you have a merge conflict, Git is going to change your file to look something like this, where it has a bunch of different sections for the different versions of the file, and you sort of just have to reconcile them and pick which ones you want. So in this case, let's say we decide that we truly do want this version right here. Right, this I wrote this print statement one. So if we go ahead and do that and then save, then here we can git commit -m fix merge conflict in example.py. No, actually that should be dealt with here. My bad. We should. I forgot to add it again. So we should just do first git add example.py. And then here we can go ahead and do that. And that is going to be how we fix our merge conflict locally. But we still have that issue of the remote version of this, right? So we would have to deal with that merge conflict remotely as well, which is just kind of a mess. And also if we look at our git status now, or sorry, actually, we're going to teach one more command right here. We can also use git log. Git log is basically just going to list an entire history of our Git repository by the commits that were made. So we can see it'll do it sort of most recent to least recent. So we had that initial commit, which this is just when we created our repository on GitHub. We had our create example.py, create remote.py, update print in example.py, update example.py remotely, which is currently what our remote is still sort of pointing at. And then fix merge conflict in example.py is what we have locally now. So now if we were to push this to our remote, it would sort of deal with that just fine. But as you can see, this sort of workflow would get extremely messy, extremely fast with you constantly having to pull things and then decide which version of them you want and do things like that. And there is a much, much nicer way to do it. And this is where we're going to start talking about branching and a GitHub feature called pull requests. So first of all, where did my terminal go? So first of all, just to get everything sort of squared off, we can just go ahead and now push our changes because we dealt with that merge issue. And if we go ahead and see here, we see that since we selected in our merge to sort of use this print, I wrote this print statement, that is what's going to end up being in our remote. But now we've seen what sort of happens if we have multiple people trying to edit the same code by just using basic sort of commits and pushes. And now we're going to discuss a much sort of cleaner way to do it. So generally, when you're working on a project, you're going to have different people sort of working on different things, right? Especially during a hackathon, you might have, I don't know, one person right now is adding something to a website, and the other one is sort of, I don't know, writing some backend code to run some sort of algorithm. So most of the time, people's changes are not going to interact with each other that much, and people are going to be working on specific sort of features. So the sort of design pattern that we're going to talk about right here is sort of called the feature branch pattern. And actually, to demonstrate this, I am really quickly going to sort of draw something for people to be able to understand it a little bit better. So we're just going to switch on over here. Is this working?
I don't think we can see it.
Yeah, it's booting up. There we go. Okay.
Yep.
So basically, we're going to talk about a super important, possibly the most important feature of Git, and that is branches. So when we're dealing with branches, all of the sort of Git things that we've seen right now has basically just been a line of different changes, right? We've had like a commit right here, and that leads into a commit right here, and that leads into a commit right here, whatever, and that goes on. But now we're going to talk about sort of how we can have those branches, how we can have our commits sort of diverge from each other and then come back in to build one cohesive sort of project at the end. So let's say we were working on a website, right? I don't know, we have our initial commit and we have two sort of contributors to this project. We'll call them, I don't know, Bob and Jane. So let's say Bob is our front end guy. He is going to build the actual sort of website and things like that. And Jane is doing the algorithms. She's going to be doing all of like the calculations and the actual, like, I don't know, the meat of the project, so to say. So to start, I don't know, let's say Bob creates the repository. And at this point, they've done all of the initial setup and they just want to work on their individual parts, which they're then going to bring together in the end. So Jane can create a branch from this project, which is going to be sort of a diversion from the main sort of through line of the thing. And she is going to, I don't know, write an algorithm, right? And then Bob simultaneously, so that he doesn't have to wait for Jane to finish, pull in all of her changes and then build his front end, is going to create yet another branch that's going to be, I don't know, creating a landing page. That's not how you spell page. So yeah, so he's going to be creating a landing page. So now once we have these changes sort of done, we could have sort of certain files that they both touch. So it would be kind of messy to have them both push, especially because, I don't know, let's say Bob has a bunch of commits on this sort of stream of things, and Jane has a ton of commits on her sort of working stream of things, right? So now they have to find a way to sort of combine the pieces of work that they did, because there would be no use in having a website front end without the algorithm that's sort of doing the cool stuff behind it. And there would be no way to sort of use the stuff from the algorithm if we didn't have a front end website to deal with it as well. So now they need to both sort of add their changes back into the original project. And the way that we're going to discuss, there are a bunch of different design patterns that people sort of use when they're creating projects. The one that we're going to sort of talk about here is called the feature branch pattern. So basically the idea behind this, and again, this is not like a Git thing specifically, this is sort of just like a project design philosophy thing, is that each of them are going to create a separate branch, which we're going to see how to do in just a second, where they're going to create whatever feature that they're working on. And then after that, we're going to merge them back together at the end to create one cohesive unit. So for this example, let's go ahead and take the place of Jane, because I don't feel like writing any sort of thing that could be misconstrued as front end right now. So we're going to jump back over here, and I'm going to switch my share back to my desktop. Okay, so yeah, so we're going to take the role of Jane here, and we're going to be writing our algorithm, let's say. So we're going to say, I don't know, really cool math.py. And def, I don't know, let's say Jane needs to write a sorting algorithm for a list. We will just leave implementation details as an exercise to the reader. If you need a sorting algorithm, this is definitely what you should be going for, though. So yeah, basically whatever. We wrote our feature, and now we want to push it to our remote, but we don't want to mess with anything that anyone else is sort of doing right now and just put it directly into the project. Because first of all, let's say, I don't know, maybe someone else on the project has to review it. We don't want to deal with merge conflicts. There are a bunch of reasons why you would create branches. But basically now, if we go back down to our terminal and we run git status, we have just what we had before, where we have an untracked file with a bunch of changes in it. So just like before, we are going to add that, or in this case, just add everything in this folder. And that is, again, going to move it to our staging area, right? So if we go ahead and check git status again, we now have it as a change to be committed. But now, let's say we don't just want to push it to main, because if we push it to main, then anyone else who's putting anything on main is going to have to pull down those changes, deal with them, and that becomes a mess. So instead, what we are going to do is we're going to use the command git checkout. So checkout allows us to basically switch between branches. So if we have this, what we're imagining right here, we can sort of think of this, you can sort of see how it's kind of like a tree or something like that. We can think of this as a bunch of different branches. So we have our main branch right here, which is this sort of through line of different commits right here, which is, I don't know, sort of the main part of the project, right? And then on either of these, we can call this, I don't know, Bob's branch and Jane's branch. We'll have actual names for them when we're doing things, but it doesn't matter. So these are sort of different versions of the project that we can see while they stemmed from something on the main thing. They have their own histories, which are completely unrelated to each other, right? Bob's branch has none of the algorithm stuff that's on Jane's branch, and Jane's branch has none of the front end stuff that's on Bob's branch. Oh, I just noticed again, sorry, I have not been great about switching my shares, but just really quickly. Yeah, so this is what I was drawing right there. We have our main branch, which is all of the sort of commits down the middle. And then we have our two different feature branches on either side. So now we're going to get into how we actually do that with Git so that we can keep things well organized. So we're going to switch on back to our desktop right here. So we wrote our feature. So now we can call git checkout. And here we're going to call -b. So B stands for branch. And this is just a way that we can create a new branch and switch to it. Checkout is just used for switching between branches. So if you have a pre-existing branch that you want to switch to, it would just be git checkout and then the name of the branch. But if you want to create a new branch, then you would use this -b flag. So we can call this, I don't know, sorting alg or something like that, right? Because that's the feature that we just implemented. So if we go ahead and run that, we can see that we now switched to a new branch sorting alg. And since I have a little extension on my shell that sort of tells me different status things about my current Git project that I'm in, we can see that this also updated to sorting alg. So now that we've switched to our sorting alg and we've already staged our change, now we can run git commit -m add bogo sort or something like that. And we can see we have one file changed. But now if we run git status, we're going to see some more information or some slightly different information than we did before. We can see here that we are on a branch called sorting alg, whereas before everything was saying that we were on branch main, right? So now if we wanted to switch back to main for some reason, we could do git checkout main. And then now if we run git status, we can see that we are on branch main. But we can also see that since we switched back to main, our sorting file, you can see right here, it's crossed out, and that's because VS Code can't find it because it's actually not in our project folder anymore. So this is not cause for concern. The file didn't get deleted. It's just that that file only exists on the sorting alg branch and not on the main branch. So now if we were to go ahead and switch back over to our sorting alg branch, then our file magically reappears right here, right? So that is basically the meat of what branches does, right? It's tracking different changes that don't necessarily have to be related to each other, although they can stem from each other. So we can have things that exist in one branch that just completely don't exist in another branch. So now we are going to sort of build on this discussion of branches to talk about pull requests. So pull requests are not a core Git feature. They're just a separate GitHub feature and have also been mimicked in a lot of other sort of Git hosting solutions like GitLab and whatever else. But basically, what GitHub allows us to do, if we were to go ahead and now that we have created this new branch and we've made changes on it, and now if we go ahead and git push origin sorting alg, so this is going to push our current branch to a branch on our origin remote, which if you remember is just GitHub server. So we're going to create a branch on GitHub server called sorting alg and make it sort of match our sorting alg branch. So if we go ahead and run this, we can see that we get a little message that comes from GitHub that tells us that we can create a pull request for it. So now if we go ahead and follow this link, it's going to open up a form right here for us to open a pull request. Basically what a pull request is it's exactly what it sounds like. You are requesting that the changes that you made get pulled, right? So just like how we're running git pull to get changes from somewhere else, here we're just requesting that people pull our changes, or in this case, that the remote pulls our changes. So here we are creating a pull request. We want it to go into our main branch, right? Because we're saying our feature is done and we want it to become a part of the main code base. And we want it to come from the sorting alg branch. So then here, just like if we were writing a commit, we can go ahead and write a title for it, leave comments. So we can say this is like add sorting feature. And our description is pogo sort is, or we can say implement pogo sort for use in our really cool project. So that will sort of leave information to everyone else on what this sort of does. And also people, before you merge this into this sort of main branch, will be able to view all of your changes and understand what they do. So now we're going to take a quick second to talk about some of the GitHub specific features right here. So we can see that we can assign people to review this. Nothing's going to show up here because I don't have any other people who are added to this repository, which is also something I will go through showing you how to do in a second. We can have people that are assigned to it. So that is basically if your project structure has like people who are managing certain parts of projects or something like that, you can have them either review your code or assign them to sort of, I don't know, merge it in or implement it or whatever else. And then there's a bunch of other sort of like project tracking features that GitHub creates for you as well. So then from here, we can see we have this green button that says create pull request. And then we also have another thing here that is create draft pull request. So this is if you want to have the pull request as sort of a placeholder, but you're not completely done with the implementation, you can create a draft pull request so that people still have an easy way to view what you're doing, but no one accidentally merges it into the project before it's ready. But now if we go ahead and hit our create pull request thing, then we will see it creates a pull request for us. And we're now on the page in the pull requests tab of the repository for said pull request. So here we can see we have a bunch of other options. First of all, there is sort of a discussion aspect to it, which is super useful if you have a bunch of people working on a project and anyone has any questions or concerns about the changes you've made, or is, I don't know, asking you to change something else. There are also a bunch of code review features that you can go. For example, you can see all the commits here. You can see the files that are changed. You can review them. So then I can write, I don't know, looks good. And I can send an approval here. But here, since I'm the author, I can't do that. Or you can, I don't know, if you spot something wrong with a piece of code, you could put request changes. And that will sort of notify the author that they need to change something. But yeah, you can add comments and that will add things to a branch. You can have a discussion about the code before you sort of pull it in. And then finally, you have this merge pull request thing, which is going to take all of the commits that you made in your branch, and it's going to merge it into the base branch. So here again, this is going to be another sort of avenue through which we can deal with merge errors and things like that. So we're not going to get into a lot of the sort of more complicated stuff that you can do this. Again, I will have resources that are going to be linked in the Discord for places that you can learn more about that. But basically, this is going to be how you then add it back into your main project. And if we see here, there are a few sort of different objects. So we can either, I got to this by clicking on this little drop down right here. If you just do merge pull request, if that option does show up for you, which won't always be true. For example, if you have merge conflicts like we just talked about, if you do this, it's just going to add your commits directly into the branch that you're merging into. But then there are a few options here which can actually help by making things a little bit cleaner. So Adding a merge commit will just do what I just said. Squash and merge. This is generally what I would recommend doing when you're doing this sort of feature thing, because you don't necessarily care about in the main branch having all of the different incremental commits that went into adding a specific feature. So what squash and merge does is it sort of takes all of those commits, compresses them down into one commit, and then from there, it only adds that into the main branch, which just makes your history later, if you're going back through your Git history, a lot more readable. And you can also do rebase and merge. So here, this wouldn't do anything in this current repository because we sort of branched from the most up-to-date thing. But you can imagine a world where you create a pull request and then a bunch more things get added into main from other pull requests or something like that. What this does is it basically makes it so that instead of branching from some old commit, it sort of moves where you branched from forward to a new commit and then adds it in from there. But again, I would just recommend doing squash and merge most of the time. So if we go ahead and do that, then we can add another title and description for it here, but we're not going to go into whatever. You can put whatever you want for those right there and then confirm squash and merge. So now here, if we go back to our code right here, we can see that it has been implemented into main. And if we go back to our local version of the repository, VS Code. So here we can now well, first of all, we can check out back to our main branch again, right? So we can do git checkout dash, or no, not dash B. We can just do git checkout main, and then we can do git pull origin main yet again. And we can see that now that really cool math thing, which disappeared for a second after I switched back to the main branch, reappeared again because we had it merged into the remote version. So that is sort of the basics of that workflow. So basically that pull that we just did, you would want to have all of your other contributors do that after you add something to main, just so that they would have those updates on their local thing as well. So we are sort of running up on my time right here. So I am going to, that is basically the basics of the workflow. I know I spoke super fast throughout that whole thing and it might not have been easy to follow. So in the last 5 minutes of this, I am basically going to go over and show you some other resources that you can use to take this at a more reasonable pace. Instead of having everything sort of thrown at you and compressed into an hour of me talking live. So the first resource that we're going to go, and this is sort of the definitive resource for using Git, is you're going to be able to get to it by just Googling Git book. So if you Google Git book, and again, there's going to be links to this in the Discord as well, you're going to get this thing on gitscm.com/book. And this is basically a step-by-step guide to doing everything that you would possibly need to on Git. The one sort of caveat here is, oh, actually, no, there is a GitHub section to this now. That's true. But yeah, this is going to be talking about Git in general, mostly the sort of local aspects of it, but then there's also now a sort of GitHub section of it, which is super useful. And from here, you can basically just go to the different topics that you need and pull things out from there. So the other resource that I'm going to show you is a lot more of a completely shameless plug. If we just go ahead and go to my channel on YouTube, if you hop on over to playlists right here, I have a playlist for shell by example, which goes a little bit more into sort of shell-based stuff, and then Git by example, which goes deeper and covers a few more sort of advanced Git topics that you might need to use. Again, links to this will be posted in the Discord. I'm not going to bother posting it in the Zoom chat just because those are going to disappear when we're done anyway. And my laptop is dying, which is great. But yeah, that is basically all I have for you. Again, sorry if that was a little bit fast. But from here, we are now going to, first of all, end the live stream, and then we are going to switch over to our sort of team matching event. So Garima, if you want to go ahead and jump in, I will stop sharing. But don't put anything up yet because I haven't ended the stream.
Don't worry.